Hello everyone, my name is Tucker Schoblad. I'm a product manager and developer evangelist here at Tableau, and I'm here today to show you how to leverage TDVT, or Tableau's data source verification tool, in order to help optimize your ODBC or JDBC based connector built with Tableau's Connector SDK. Before we start, there are a few quick requirements. You're going to need a Windows or Mac OS machine. You're going to need to install Python 3.7 with a quick note to enable the install of environmental variables. You'll obviously need the ODBC or JDBC driver for your database. You're going to need Tableau Desktop 19.4 or newer installed onto the machine with a valid license. And lastly, you're going to need to install or load the test v1 tables, calcs, and staples into your data source so that Tableau can connect to them. To give this guide a quick summary, the goal of it is to help you understand what TDVT is, what it does, and really how to understand the results of running this test suite in order to improve and optimize your connector. So what I mean by that is that we're going to look at the results of a TDVT run that have some faults and understand why that is the case, what I need to change about my connector, and be iterative. Change up my dialect file, make improvements, and see those test case failures drop down to 0. If you've made it this far and are thinking to yourself, I'm not really sure what the Connector SDK does, what it offers me, or how to get started with it, this might not be the best guide for you. This guide is more of a deep dive into TDVT, which is an integral part of the SDK. If you're looking for more of a 10,000-foot overview of the SDK itself and how to get started, I'm going to recommend this excellent YouTube video. It's a TC presentation given by two of the engineers who actually built the SDK itself. So if you're looking for more of that, again, just 10,000-foot view, I'd recommend you check this out first and come back to this guide when you're ready to dive into TDVT itself. So what's going to be covered in this guide? Well, we're going to start by creating a workspace and installing TDVT. Next, we're going to configure the environment to work with our data source. We're going to run our first test of TDVT. We're going to leverage a Tableau workbook packaged with the SDK to help understand these test case failures and diagnose them. Lastly, we're going to update our dialect, rinse, and repeat until we have a beautifully working connector. With that, let's dive in. So first things first, we need a workspace to run and install TDVT in. Now, I've created one called TuckerDB Workspace. I called it TuckerDB because that's my name, and it's also the name of the fake connector that we're going to be troubleshooting throughout this video. So let's change into that directory. At this point, you're either going to use Git or manually download the repo Connector Plugin SDK from our GitHub page. So I'm going to go ahead and clone it here. I'll copy the code and run git clone to the Connector Plugin SDK. Awesome. So if we look in our workspace now, we actually have the entirety of the Connector Plugin SDK within this directory. We're going to need this to actually install TDVT. First things first, we're going to go ahead and switch into the directory from the plugin SDK. We can see all the available subdirectories and files here. And we're going to change into the top level TDVT folder. If we actually look within this one, we see another folder called TDVT, but we're going to hang out in just this top level directory where we see the setup.py file. Once here, we can use the following line to create an archive from which to install the test suite. Add an extra dash there. So we're running the setup.py file and formatting it, the output of it as a gztar file. So let's go ahead and do that. Okay, so a lot of stuff just happened, and we can ignore this little warning down at the bottom because, importantly, if we look at our directory, we have this new folder called dist. So we can change into dist and see that we have this tar.gz archive of TDVT. So now we have the ability to run Python in a module, pip install, and then we can go ahead and autocomplete the rest of that file, TDVT version 2.1.22 in this case. So let's go ahead and run that. Okay, as we can see, if we run pip list here, we'll find this new and improved version of TDVT installed onto our machine. Perfect. Now that TDVT is installed, let's use it to create a workspace to run our tests from. I'm going to type python -m TDVT dot and pause. A lot of our documentation lists instructions on how to use TDVT without this really important prefix. So depending on your version, you might need to do python -3-m.tdvt, but this is what it's going to look like every time we do something with the data source verification tool. So in this case, we're going to run action with the flag setup. So what we're doing is we're telling TDVT to set up our environment. We can do that now and see that it properly created our setup files. It's prompting us to set the tab query executable. We can also quickly just look at what all of the available methods are within TDVT. Oops, let's do, instead of list, let's do help. So we can see that you have the ability to list the data sources and suites. We're about to create one, so we don't have any yet. That's why that list there returned nothing. We can list logical configs. We'll get to that in a little bit. It's basically how TDVT knows how to communicate with your data source, things like uppercase and lowercase table names and such. We have actions for running tests, running different patterns and files. We're not going to get into the patterns and files so much in this video, but we'll definitely use action like we did with setup. And we also have, these optional arguments for help and verbose output. So that's pretty much what's possible just by typing TDVT and then something else, right? So now that we've run setup, we can see that we have these new folders. We have config, we have TDS, and we have these log files, which are going to be important down the road. We obviously still have the cloned SDK itself in this directory, but for now, I'm going to open up a text editor, and we can actually get started configuring our environment to run TDVT. So I'm working in VS Code here. Really doesn't matter which editor you choose to use, right? But I just use VS Code for everything else, so we're going to use it here. I'm going to navigate into this config-tdvt directory and open up the TDVT override here. This is our first little config step that we need to do. Now, the idea here is that we're telling TDVT how it can use Tableau's query tool to simulate these end user behaviors that TDVT tests for. So this is why it's important that we have a valid licensed version of Tableau installed on this machine, because what we need to do is point TDVT at some specific subdirectories. And formatting aside here, we can see that we've got two options for Windows and Mac. I'm including both. Obviously, I only need the Mac one, where we go to Applications, wherever Tableau is installed. We actually go into the contents, so .app contents Mac OS, and we point towards this tab query tool. Very similar with Windows, just wherever you installed it, whichever drive. Just make sure that you get to this .executable. And again, make sure that this copy of desktop is licensed. That's an absolute must here. So now that we've saved that, our workspace is almost good to go. The next step is to open up Desktop and create some .tds files or Tableau data source files. So let me open up a fresh window of Tableau Desktop now. Our next step is to create two data sources with connections to the tables from test v1 that we've loaded into our data source. Now, if you haven't done that, this is a prerequisite step for building these data sources. So on the screen here, you can see the link to how to get to the test v1 tables documentation. I'm going to have to leave it to all of you to go ahead and load those tables into your data source on your own. So at this point in development, I'm not really assuming that you have a packaged .taco file, much less a signed .taco file that we're working with. And I assume that your connector actually looks like my TDVT connector does here. With these disparate XML and JavaScript files, you can see we've got our dialect, we've got the connection resolver, the manifest. We can actually just quickly open maybe Sublime Text here and see what these look like, right? We've got the manifest, TDVT. This is the class that I've set. It's an ODBC based connector. The dialect is empty. We're certainly coming back to that in a little bit. Everything else, this sets up the interface when you connect. It's got the resolver. It builds the string. But in any case, we need Tableau Desktop to actually connect to, we need Tableau Desktop to let us use this connector, even though it's not a signed package.taco file yet. So to do that, you could, pretty easily open Tableau Desktop from the command line and navigate to your applications folder in Tableau Desktop. But I find that personally a bit cumbersome to do every single time. So instead, I've used the AppleScript editor here to create a shortcut. And what this shortcut or this AppleScript that I've created allows me to run Tableau Desktop with some flags present. So this is what that looks like here. I run the -d connect plugins path flag after Tableau, right? And I point it to where my unpackaged connectors or connector lives. So in this case, it's in my home user directory /Tableau Connectors. So again, that's what we're looking at here. This TDVT flag or folder lives within tshowblad, Tableau Connectors, and this is where I have all my unpackaged files. So if I open Desktop using this applescript.app that I've saved here, we can see that without any work from the command line in this case, we have TDVT by Shobi Corp right here on the list. And if you're on a Windows machine, you can take advantage of a similar sort of trick here. In this case, I just created a shortcut to open Tableau Desktop. Again, in this case, version 2020.3. And in this target here, where if I maybe scroll a bit more slowly through it, we can see that we're launching Tableau.exe with, again, the -d connect plugins path leading to the folder with my unpackaged Tableau connector. So I save that shortcut and, again, can really easily launch it without needing to go through the command line every time. Okay, so turning back to my Mac machine with our TDVT workspace set up, I'm going to use the TDVT connector, again, the one that we want to run TDVT against, and connect to an instance that has our test v1 tables loaded. So I'm going to do that right now and cut to the end result. All right, so we can see that I'm connected to my test v1 database in my TDVT instance, and I have probably a bunch more tables than you all might, but again, the ones that we really care about are calcs and staples here. So it's these two that we want to create these .tds or data source files for. They're going to help TDVT kind of point the query tool in the right way and kind of know what the tables look like, the columns, their types, so that it can do all the proper testing. So first things first, let's just grab the staples table and we'll bring it up to this top pane here. We can quickly hit update now just to see a view of what's in these tables, a bunch of shipping data, sales, discount rates, and all that. Importantly, we're going to leave this as a live connection, and we're going to go up to the top here and rename it with a very specific convention. So in this case, we want to name this staples.tuckerdb. Now, we're naming it staples because we're using the staples table in this case, and the .tuckerdb indicates the test suite that this data source file belongs to, in this case, my TuckerDB suite that we are going to go ahead and create soon. So now that I'm here, I can jump into a worksheet and right-click on the name of this data source in the top left, and we're going to go ahead and add it to saved data sources. So we're going to save this .tds or Tableau data source file to the TDS folder within the workspace that we've set up. Again, keep in mind this name of staples, capital S, .mydb, the data source name, .tds, and we can go ahead and save that here. Now, I'm just going to click back up in Tableau Desktop, and I'm going to do it one more time, undo again, until we've pulled off this staples table from this top pane here. We're going to do the same thing with calcs, where we drag it out onto our view. We can go ahead and update it. We can see that this table is structured much differently. And I'm going to name this one cast_calcs.tuckerdb. And again, we do that because when I come into a new sheet here, sheet 1, I can right click on it, add it to my saved data source list, and follow this same naming convention in this TDS folder of our workspace. So we'll go ahead and save those. And for now, we can actually quit Tableau Desktop. Okay, so we're back at the command line, and we can see that if we navigate to the TDS folder of our workspace, that we've got these two data source files that we created with, the specific sort of suite name right here, TuckerDB. In this case, you're going to name it whatever you'd like, whatever's appropriate for your database. But we want to be really careful to make note of this naming convention, because the next thing we're going to do after heading back to our parent directory is run python-m TDVT, so this convention that we discussed earlier, and run action add ds tuckerdb. So what we're doing right here is we're creating a suite to test within. And the first thing it says is make sure you already have the TDS files in that directory. We were very wise to do that before actually doing the action add ds command here. So I'm going to go ahead and create a password file later. So I'm going to say no in this case. I don't have to show you the password. And it's going to ask for our logical config that we want to see. And in this case, we're actually going to hit S to skip this one now. It's going to write a bunch of tests, and we'll check back in after it's done. So with the magic of video editing, all of the tests have been generated and written. You can see in my TDS folder here that I've added my own .password file. And if we head to config, we have a new .ini file that has some really important configuration steps. So let's turn back to VS Code and take a peek at what that looks like. We can see the tuckerdb.ini file here. And importantly, we need to set what's called our logical query format. So again, I alluded to this earlier, but it's how TDVT knows to communicate with your data source. So to do that, we're going to do two things. The first is open both of these TDS files, so staples and cast_calcs, in a text editor. These are just XML, even though they've got the .tds ending. And the next thing we're going to do is come back to our workspace and run list logical configs. So running this through TDVT is actually going to give us this big list of all of these different logical query formats that Tableau can kind of assume when it goes ahead and gets ready to query your data source. So in order to figure out which one is right, what we do is we can scroll way down here. And let's look at these lines, maybe 480 and down, in our case in cast calcs, where we can see the name for bool 0. We can see what date 1 looks like. We can see just how Tableau is formatting these different column names. We can come back up and see things like the table and schema format. So this is public.calcs. That's really important. So why that's important is because we're going to turn back to this big list and actually realize that these should all match up. And in this case, it looks like simple lower could be pretty close, but we actually need to get this public prefix right. So it could be, in this case, simple public that satisfies all the conditions we have for how the table structure looks formatted in this data source. So very important that we've got the schema getting properly notated here. Bool 0 looks good. Again, let's just scroll down all the way to the bottom of cast calcs here. We can see that we've got bool 0, bool 1, so on. Maybe if we even turn over to staples, which kind of has more real-ish looking data, if we scroll all the way down again, we can see things like camel case getting denoted here, where it's not all lowercase, it's not set with an underscore in between these column names. So I'm pretty confident that we're going to go ahead and go with simple public here. So let's turn back to our INI file, and we can simply type in simple underscore public for our logical query format. Now, if one of those on this big list here doesn't satisfy all of the conditions, or maybe once we get a bit down the road, you start running tests, these smoke tests, and nothing's working, you can actually create your own logical query format. And the link up on the screen here actually goes straight to our documentation, where it lays out all of the different possible options for how you can set up your own logical query format. Not very difficult, but sometimes a necessary thing to do as we keep going here. Now, our last step before we actually start running some tests is we want to add a command line override here. So this is Great. So this is very similar to what we did when we created those shortcuts to launch Tableau Desktop. We basically need in this .ini file here to set this dconnect plugins path pointing to the connectors folder with our unpackaged .taco file. So all of that XML that we looked at, we need again to point towards this folder. So we can go ahead and save this, and we'll minimize here, and we can turn back to our command line. Now we're really getting to the good stuff, because we get to run TDVT and run a full test suite and see what the results look like. So let's do that now. I'm going to go ahead and again type this prefix TDVT. We're going to run name of the test suite, TuckerDB in this case, and I'm going to add this generate flag here. So why I need to use this generate flag is because we need to rewrite some of the XML that the test harness uses, and we need to rewrite some of it because we changed the .ini file. So whenever I make a change to the TuckerDB or mydb.ini file, that's when we need to actually add this generate flag to this run command here. Now, if I were to just go ahead and change something in my connector, let's say the dialect file or the manifest of it, I do not need to re-add the generate flag. Again, that's only when we change something about our workspace itself. But in any case, let's hit enter here. it's going to have a lot of output on the command line, so we'll check back in right after it's done. Okay, and we're back. We can see that my test suite finished running in 91 seconds, so just a minute and a half. Pretty good time here. We can see that 841 tests were run with 16 failures. So 16 failed tests out of the total 841. That's pretty good. We're going to dive into why those tests might have failed and try and learn something and update our connector to make it better. But first, I want to cover a few scenarios that you might be experiencing. First, what happens if no tests pass? Let's say, I can't even connect to these tables. Something's going wrong. Well, first thing I want you to double check is that the password file is set up correctly. And you can test that by opening these data sources from Tableau Desktop, the one that we created the shortcut to, or the one that you launch from the command line. Hit Command O and open one of those data sources. Make sure that you can drag and drop something without the need to type in a password. This is just a sign that the smoke tests are failing. And one way that we can actually just quickly run these smoke tests without making any big changes to our setup is by doing run mydb or tuckerdb and then using the verify flag here. So let's go ahead and try that out. All it's doing is creating these smoke tests and running them, making sure that it can actually hit those database tables and get a result back. We can see that both of them ran. We have no failures here, so that's fantastic. The next thing that you might want to try is checking the data validation, making sure that things are loaded properly into the tables. And so to do that, we've got this INI file here where you can go ahead and delete everything below data source in the command line override. And instead, we're going to add these. So we've got the calcs data tests where we're running this kind of specific set of test instructions, and we're running the staples data test. So if I were to do that, I could just, copy and paste this here. Let's head back to our INI file. Paste that in. And, we don't want to leave everything hanging, so we can just go ahead and comment these out so it's easy to get back. Undo is probably also our friend, but we'll save that. And again, we'll use generate since we changed something in the configuration. We'll run generate here. And what this is going to do is just make sure that it's getting the data types, it's getting the column names, that everything is as expected. These are just two quick ways to validate when you're in the scenario where a whole lot of tests are failing or every single test is failing. I'm also going to direct you back towards our documentation in this case, since we have a lot of different kind of scenarios and workarounds to some of these problems that you might be experiencing. So we'll go ahead and put that link up on the screen. In this case, we can see the data is loaded properly. These 27 tests all passed. That's great news for us. Now we can get back to figuring out what's going wrong with those 16 failures that we called out earlier. So behind the scenes really quickly, I made a small change to our test environment. This just removed 2 of the tests. It's just for the sake of this video. I'm not going to step through it in this case specifically. But in any case, we can see now that there are 14 failed tests, and we want to learn why these tests are failing because they obviously are going to impact end users who use our TuckerDB connector. If we head back to our workspace, we can see there are a bunch more files here. This includes the test results combined.csv. This one is really important. It's the result of what TDVT just did. It's going to have 839 rows, one for each test. We've got that same data in JSON. We have logs about what TDVT did, maybe if it had troubles. It also, some of that is included in the tab query logs and these TDVT actuals. These bottom 3 here are super important to when you're trying to troubleshoot something that may not be immediately obvious through the workbook that we're about to dive into. So This workbook right here, TDVT results.twb, it's actually found in the cloned repo here, the Connector SDK. I just moved it from this TDVT folder here back into our working directory. And we can also see these this file test metadata.csv. It's another really important thing to help understand what each of these test cases is trying to do and learn more about, say, whether it's required to pass this test for the gallery. And that's going to be found in TDVT, this TDVT directory. So the second level TDVT under metadata, that's where I just copied this test metadata file. So I like to bring those into my working directory for the workspace. So this top level workspace directory. And let's go ahead and open this workbook to start to get the hang of what's going on with these test case failures. We could certainly look at it in Excel, but that's not the way we do things here. It comes packaged with this handy workbook. So first things first, what we want to do is make sure that we're pointing at the right place. And we do that by coming down to this data source tab in the bottom left. Hit edit connection and just make sure that you're pointing at this test results combined.csv file in your workspace. That's where you want to be looking. You could do the same thing with this test metadata, but chances are that if you brought the TWIB and those two text files into that same folder, that you shouldn't have any problems there. One other thing to check if the data looks really weird is just make sure that text file properties is set to this double quote text qualifier instead of automatic. So if I click here, we want to make sure that that's on the double quote. And lastly, we can just make sure that the relationship is defined properly by clicking on that little bar. We want to make sure it's linking from test name to test name categorized in this case. Okay, so let's get a sense of what's going on with this dashboard. Well, first of all, we can see that we have the total number of tests passed and failed up in this top little scorecard. And we can see the different test categories that TDVT operates under. So we're doing really well in a lot of these until we get down to cast and string tests here. So these two test categories are resulting in these 14 different test case failures. Now, it's really helpful to hover over each of these bars on the right-hand side because we can see actually what the error message we're getting is, what the test case is, whether it's, required or only maybe recommended. But in this case, I actually am going to hit this little drop down here and switch from priority to this error option on the parameter swap here. And now we can see, what the output is from these tests that, were the result of Tableau and my data source and my connector just not all being on the same page. So we see a couple of patterns. First of all, in this case, our dates aren't getting casted properly. It doesn't know how to handle a date, with a string in it instead of just a floating number. That's evident in both of these errors here. It doesn't seem like I have the function find built into the dialect that I'm working with. So in a second, we're going to turn back to a dialect file and open it up and add some functions that will help take care of this, but doesn't know what the find function is, and it doesn't know what the write function is. So it's telling me that these unknown functions are called and that I'm unable to cast data in a way that I'd like to between these data types. So this has been helpful for me, but let's say I wanted to learn a bit more. We've got a couple of ways that we can interact with this workbook actually. So one of them is I can click on an entire error message. So maybe this unknown function find call. And from the menu action in this Tableau dashboard, I can go to actually filter by that type of error. So in this case, we can see a lot more information like the generated SQL. In this case, there isn't any because the test failed. We can see the expected tuples that we want to get back versus the actual tuples that we get back. This is helpful for diagnosing maybe, like something like a date diff. If your days are one off or a week off, or it's not handling the start of date correctly, that's a pretty common error that we see. Comparing this generated SQL with the actual and expected tuples can be really helpful. And if I wanted to dive into a particular test, I could always click this square, view the details, and jump into a single worksheet that highlights only the results of that given test. And that's what we see here, that this unknown function find is called. Just a bigger view in case there's more going on. We can see in real detail what's going on with that single failed test. Now, jumping back here, I've got a good starting point. So maybe the starting point, my starting point here is that we implement this function right. We could do right and find here just because they're not built into our dialect. So I can actually go ahead, just minimize this for now, and let's turn to our dialect file. So this is my unpackaged connector again, and we can see that I'm starting off with PostgreSQL, which is TuckerDB is very similar to PostgreSQL, but there are a few key differences to it, and that's coming through loud and clear because we actually notice that I don't have two of the functions that Tableau requires that I have if I want to give a good experience to my end users or eventually get this on the gallery, right? So now the idea is we want to add a function that's not available in the base SQL dialect that I chose, but add it to my own connectors dialect. So if you're confused about what this should look like or an example of this, I'm going to point you towards this resource, the full dialect.tdd found on our GitHub here. This just shows, if you were to not use a base dialect, this is what is implied by all of these different functions. And we get the chance to overwrite them. But in this case, you can see that we simply add these functions one at a time, kind of leaving space for the input there. So in SQL, specifying the argument type, what it's returning. So if you can think about our casting problem that we're having with dates, that's going to be very important here. But in any case, just a resource to have on deck as we step through an example of solving something broken in a dialect here. Okay, so first things first, we got to create a function map. So that's what we're going to do here. We're going to say function map. And we'll just leave a placeholder, and then we'll close that out. Great. So these are where our individual functions are actually going to live, right? Now, the first one that we picked was, we could do any of them. Let's do find. Let's add find. So we're going to create a new function like this, like so, and it's going to be group. It's this is a string function. Find is a string function. So we'll do single quotes string. Name of it is going to be, oh geez, Louise. It's going to be find. It's going to return an integer, the placement of it, so we can close off this item, and then we can actually input the formula. And so because I'm an expert in TuckerDB, I know what this SQL looks like, right? It's going to be kind of, at your discretion, knowing the best syntax to implement a bunch of these functions. But we're going to go ahead and do it like this. And then close out our formula member there. And then we need to set some arguments too. So that's the %1, %2. These are our arguments getting passed in. So argument is going to be type. Oops. Keep needing to delete a bunch. String. We can close that one. And then we also want to leave room for argument type string for number 2. All right, so we just added our first function. Awesome. Let's go ahead and actually run this. See what's going on. Oops, before we do, let's be sure to close our function. All right, there we go. So now let's just head back to the terminal here. We can just run TuckerDB. We don't need to do generate again. So we're just going to run it, and then we'll check back in with the results. Hopefully it has ticked off a few of those 14 failures. So check it out. Now we only have 10 failed tests, meaning that we solved 4 of our failures by manually adding this function in. And that's fantastic. That's the road to eliminating all of these test case failures is knocking off these scenarios one at a time. I'm back in my my workbook now. I'm going to go over to data, hit refresh here. You could hit Command R as well, and we'll see the results of that in a second here. Drop down to 10. That's perfect. So what did we just try and fix again? Right? We tried to fix this find function. But looking at our data, at the results, even after implementing that fix in the dialect, there are 2 of these cases that still aren't getting covered, and it's when we actually send the find function with 3 arguments instead of just 2. So this one goes string integer, meaning we want to find the nth copy of a string within a substring, right, or substring within a string. Excuse me. So we haven't implemented that fully yet, and I want to do that here now, but I definitely don't want to type all of it out. So what I'm going to do is recommend that you either use that full dialect or one of our other sample dialects available in the GitHub SDK, and we can actually just start copy and pasting some of these functions, just a bit of trial and error to see if it solves everything. So in this case, I want to add a new function. Here it is, just copy and pasted it. Again, it's find, but this actually takes 3 arguments, the string, and real versions of these arguments that we saw, in these test cases where we were still getting those failures. So I'm going to go ahead and save that. Let's now turn to some of our other issues that we were seeing, maybe like this write function. This write here doesn't know what that function is. So we could again turn back to our dialect. Let's leave some room for a new function here. I don't think the XML is particularly picky, but I like things to be formatted. So we'll come to a new function, and this is what our write function is going to look like for TuckerDB and the variant of SQL that TuckerDB uses. So again, this is all the SQL that's going to get generated when write gets called. As of right now, our connector doesn't know how to do that. But again, if we were to rerun TDVT here after having added this function, hopefully we'd find that our new dialect, this new version of this dialect, would actually solve these problems. The last one up is a different type of function. So far we've been working with these string functions, right? But another problem that we saw was with the casting, right? We saw that we couldn't cast a date, from this type string. So this is what the kind of the antidote to that problem looks like, is that we have this new group cast function with this date function. It returns a date type in Tableau. But we can see that the argument is actually set to allow a string to be passed in as well. So that's the fix to this function here. Let's go ahead and save it. We'll run TDVT one more time, and hopefully at the end of it, we'll find that all of our tests have been passed. So good news, everybody. We have passed all of the tests, 839 of them, 0 failures, and it's all thanks to really what's an iterative process of diagnosing an error, figuring out whether it's not supported or whether you need to overwrite the SQL that's being written to support the flavor that your database, that your product is used to. adding this function into the dialect, rerunning, testing to see if that fix worked, and doing that until you've knocked out all of these what we call required failures. So if we go ahead and refresh this connection to our data source here, I'll do that now, we can see that, look at all this green. We've passed every single test in TDVT, which is fantastic. I'll maybe quickly note that if you are interested in submitting for the gallery, it's not required that 100% of TDVT tests pass, but we do have a very high bar, and it is subject to a case-by-case review to hand wave any particular failures caused by incompatibility, or maybe small things like trailing zeros. Tableau expects an integer value back, but your database returns some trailing zeros. That's something that might not be a big deal, but again is subject to a more case-by-case review. So again, if we're just thinking about some resources to help be efficient when building your dialect, I'm going to point you towards the GitHub repo for our SDK. Now, I already mentioned this full dialect. It's a great sort of sample, a place to start from scratch if you do need to build your own dialect from scratch. Some great advice on how to build these functions here. We also have some more specific examples. So in this case, this is a Postgres dialect. So when I inherited this base dialect of PostgreSQL, what's actually going on under the hood are all of these functions. So these could be helpful to me if I know that my database is similar to Postgres in how it handles queries. All of this is found in the samples folder here on the GitHub with different components or full plugins. Really great starting point to building your connector or checking out different types of dialects and different functions to see if those might help pass different test case failures. So to wrap things up, first just want to say a big thank you. You made it through this long video on TDVT, how it works, how to set it up, create your workspace. We learned how to run our first tests, improve our dialect, use the Tableau workbook to learn more about the context of the test case failures we were seeing, write new functions into our dialect, and make our connector even better. So thank you for joining me on that journey. I'm sitting here in the editing bay and realizing it definitely got a bit longer than I thought, but there was just so much good stuff to run through. How could I not? In any case, if you have some feedback for this video, please drop a comment below, like it if you like it, the whole YouTuber spiel. If you want to connect, the Tableau community is a great place to do that. It's not just for desktop users. If you have questions about using our different APIs, there's lots of great resources available there. If you want to join our developer community, I highly recommend you check out tableau.com/developer. And if you're having any issues with the SDK, you can raise one with our engineering team here, get in direct contact with them, usually quite prompt. In any case, thank you all for joining me on this journey, and I will see you all next time. Cheers.